This is a key to the worksheet on scientific notation. So in problem number 1, it says write this number 23, and then you have 3, 6, you have 9 zeros behind that 23. So let me go ahead and just rewrite this over. So we have number 1, 23, and then 9 zeros. And so you want to put this in scientific notation. So remember, a number in scientific notation, and I'm going to go ahead and write it like this for right now, a times b to the, a times 10 to some power b. So this a that you're looking at here, the coefficient, must be a number between 1 and 10. Now, remember I said a number between 1 and 10. So particularly though, I could write a little bit better and say that a must be less than 10, and at the same time, it has to be greater than or equal to 1. All right, so a one-digit number, so we can say a one-digit number that is between 1 and 10. All right, so including 1, but not including 10, because 10 is a two-digit number. And so basically what you're going to do is in this whole number right here, this is a whole number, the decimal point's understood to be here. And what you want to do is bring it all the way until the decimal point is between the 2 and the 3, because that's that first non-zero number. So that digit must be non-zero, by the way. It has to be between 1 and 10, not including 10, because 10 has two digits. So notice when I bring this decimal point all the way, I'm going to put it between 2 and 3, because now I have only one non-zero number in front of that decimal point. All right. Now, I've got to count how many place values there are. So whenever you move a decimal point, you're either to the left or the right, you're multiplying it by a power of 10. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I moved my decimal point 10 places to the left. All right, so it looks like this. 2 times 3 times 10, and I moved it 10 places to the left, right? So I'm going to put a 10 as the exponent. So that b determines the power of 10. So I moved the 10 places to the left. Now remember, you got to determine whether the exponent is positive or negative. So remember, this is a number that's bigger than 1, right? So that's a number bigger than 1. So that means that your exponent must be positive. So whenever you move the decimal point to the left, whenever you write a number in scientific notation and you move the decimal point to the left, that exponent is positive. So that's the first one. So the first one is 2.3 times 10 to the 10th power. The second number was this one right here. So I'm going to go ahead and rewrite it over. So here's number 2. Number 2 is 0.000025. Now, just like before, I want to put this number that's in standard notation in scientific notation. So I'm going to move the decimal point to the right this time, because this is not a this number right here in front of the decimal point is non-zero. I mean, it's 0 rather. I cannot have a 0, so I got to move it all the way. Move it all the way, in this case, to the right, until I put the decimal point between the 2 and the 5. So then I would get only one non-zero digit in front of the decimal point. So this becomes 2.5 times. Now, whenever you move the decimal point, you're actually moving by a power of 10. All right. So in this case, though, I'm moving at 1. You count the places. 1, 2, 3, 4, 5. So I'm going to say times 10 to the 5th, but then you have to determine whether that exponent is positive or negative. So notice, if you leave it positive, 10 to the 5th is a very big number, and multiplying by 2 is a number greater than 1, a big number greater than 1. And this number here is less than 1 in it. 0.00025 is less than 1. So this has to be negative. So whenever you change a number to scientific notation, and you move the decimal point to the right, the exponent must be negative. All right, number 3 is just like number 2, except you have more digits to deal with. So you have 0.00, let me count the zeros. There's 1, 2, 3, I'm right here. So 1, 2, 3, 4, 5, 6. So there's 6 zeros. So 1, 2, 3, 4, 5, 6, and then 4, 3, 8, 7. All right, so this is a number less than 1. This is a 0. I cannot have a 0 in scientific notation. So I'm going to move this decimal point all the way until I get between 4 and 3. So I'm going to put the decimal point here. So then I would have one digit in front of the decimal point. So I'm going to get 4.387 times 10 to a power. So the power is how many places you've moved that decimal point. So I went 1, 2, 3, 4, 5, 6, 7. But then you got to determine is it going to stay positive, or is the 7 positive or 7 negative? So remember, this is a number less than 1. So if I leave it positive, that's a very big number greater than 1. And so I need to make it negative. So whenever you move the decimal point to the right, your exponent is negative. All right, number 4, you want to take this number here, and that's in scientific notation, you want to put it in standard notation. So you're kind of going backwards in what we've been doing. So number 4, we have 3.45 times 10 to the 6th power. All right, so notice that this exponent, this power of 10, this exponent is positive. So that means that this number has to be greater than 3.45. So we're going to move the decimal point to the right, and you're going to move it to the right 6 times. So we're going to have 3.45. So here we go. We're going to say 1, 2, and then 3, 4, 5, 6. All right. So this becomes 3, 4, 5, and then 4 zeros. So let's see, that's a 3. Okay, so I just put commas in the right place. And so there's the answer. So 3,450,000. Okay. Number 5, you have this one. You have 7.3 times 10 to the negative 5th. That's number 5. So it's written in scientific notation, but you want to put it in standard notation, just like we did this one. So notice that the exponent is negative. So it means that this number here, since the exponent is negative, this number has to be less than 7.3. So since it has to be less than 7.3, that means I'm going to move this decimal point to the left 5 units. So I'm going to go 1. All right, so remember 5 units going to the left. 1, 2, 3, 4, 5, and then put the decimal point in front. And so since, and in mathematically, we tend to, if there's a decimal point here, we tend to put a digit here, and that digit is 0. So this becomes 0.0000073. So that's the answer to number 4. All right, number 5 looks like this. All right, so here's number 5. Oh, number 6, actually that was number 5. Number 6 looks like this. So this is number 6. So number 6, we have 6.385 times 10 to the negative 3rd. So we have this number in scientific notation, and I want to put it in standard notation. So notice the exponent. The exponent is negative, so that means that this number that's in scientific notation has to be less than this coefficient. So that means I have to move the decimal point to the left. So we have 6.385, and we've got to move it to the left 3 units. So 1, 2, and then 3. And we put a decimal point there. And we're going to put a 0 as a placeholder in front of that decimal point. And so therefore the answer is going to be 0.006385. And so that is number 6. All right, number 7 is where, if you notice, is where we're going to start multiplying 2 numbers that are written in scientific notation. So let me go ahead and rewrite this over. So we have 6.1 times 10 to the 3rd times 3.2 times 10 to the negative 8th. All right, so to put this in scientific note, to write this product in scientific notation, remember all this is multiplication, and multiplication is commutative. The order in which you multiply does not matter. So I'm going to put the coefficients together. So I'm going to say in parentheses 6.1 times 3.2. And then I'm going to put the powers of 10 together. 10 to the third times 10 to the negative eighth. And so I'm going to multiply the coefficients together now. So I have 6.1 times 3.2. And we multiply 2 times 1 is 2. 2 times 6 is 12. 3 times 1 is 3. And then 3 times 6 is 18. And we add them up. We get 2, 5, 8 and 1 is 9, and then 1. And then there are 2 digits behind the decimal point. So I need 2 digits here behind the decimal point. So 6.1 times 3.2 is going to equal 19.52. So this is 19.52. All right. Now, over here, remember the product rule. So the product rule for exponents says that when you multiply like bases, you add exponents. So that becomes 10 to the third plus a negative 8. So when you multiply like bases, you add exponents. Well, 3 plus a negative 8 is a negative 5 in it. So I get 19.52 times 10 to the negative 5. But this is not scientific notation, because remember scientific notation, so do not put that as your answer. Scientific notation, you have to have 1 digit in front of the decimal point. You have 2 here. So what we have to do is to rewrite 19.52 in scientific notation. So I'm going to move the decimal point to the left. And so when I move the decimal point to the left, I get 1.952 times 10 to the first power. So whenever you move the decimal point to the left, when putting in a scientific notation, the exponent is positive. So that's this. So I'm going to rewrite this right here using scientific notation. So I get 1.952 times 10 to the first times 10 to the negative fifth. And just like we did here, I'm multiplying like basis, I'm going to add exponents. So this becomes 1.952 times 10 to the 1 plus a negative 5. And then 1 and negative 5 is a negative 4. So I get 1.952 times 10 to the negative 4. And that's the answer for number 7. All right, so notice all the work you had to do to get this answer in scientific notation. And notice we had to do some work here as well. So we had to multiply decimals. All right. Okay, number 8. So number 8 is this. You have, in number 8, you have 8 times 10 to the negative third times 4.1 times 10 to the negative fifth. Just like we did, all this is multiplication, so I'm going to group the coefficient together and group the power of 10s together. The order in which you multiply does not matter. So 8 times 4.1 times 10 to the negative third times 10 to the negative fifth. All right, 8 times 4.1, that's going to be 8 times 1 is 8, 8 times 4 is 32, 1 decimal place. I get 32.8. All right, so this becomes 32.8 times, and then again, product rule for exponents. When you multiply like bases, you add exponents. So that's 10 to the negative third plus a negative 5. And so I get 32.8 times 10. A negative 3 to negative 5 is a negative 8. All right, now just like we did a while ago, this is not scientific notation because there are 2 digits behind the decimal point. So we got to think about what 32.8 is in scientific notation. So I'm going to take this decimal point, I'm going to move it 1 place to the left. So it becomes 3.28 times 10 to the first power. So I'm going to take this right here, put it here. So that becomes 3.28 times 10 to the first times 10 to the negative 8. And then doing that same product rule, when you multiply like bases, you add exponents. I get 3.28 times 10 to the 1 and a negative 8. 1 plus a negative 8 is a negative 7. So your answer is 3.28 times 10 to the negative 7. All right, that was number 8. Number 9 is a division. So the 7 and 8 was a product, but number 9 and 10 will be a division. So we have 2.08 times 10 to the third divided by 2.6 times 10 to the 8th. All right, so just like we did with multiplication, I'm going to group the coefficients together. I'm going to group the powers of 10 together. So this is 2.08 divided by 2.6 times 10 to the 3rd divided by 10 to the 8th. All right, now let's go ahead and do this division here. So we're saying 2.6 divided to 2.08. And so since the divisor is not a whole number, we're going to move the decimal point one place to the left. I'm sorry, one place to the right. We do the same thing here, one place to the right. So you're really dividing 26 into 20.8. All right, so move the decimal point up. 26 into 20 is 0. 0 times 26 is 0. So you subtract, you get 20, and then bring down the 8. So we got to figure out how many times 26 goes into 208. So for example, if you say 7, 7 times 6 is 42, and then 7 times 2 is 14, plus 4 is 18, so that's not, it could probably go one more. Let's do 8. 26 times 8, 8 times 6 is 48, 8 times 2 is 16, plus 4 is 20, all right, that's it. So 26 goes into 208, 8 times. 8 times 26 is 208, remainder 0. So what we found is that this right here is 0.8. Now you can always check your work, right? So you're saying 2.08 divided by 2.6, and you get 0.8. All right, now remember in the previous problem, we used the product rule for exponents. Here, we're using the quotient rule because you're dividing. So remember, the quotient rule says when you divide like bases, you subtract exponents. And it's the exponent in the numerator, subtract the exponent in the denominator. So that's 10 to the 3 minus 8. And so this becomes 0.8 times 10, and then 3 subtract 8 is a negative 5. Now remember, this is not scientific notation, so that's not your answer, because you got to remember, in scientific notation, that one digit in front of the decimal point must not be 0. So let's think about what 0.8 is in scientific notation. So to get that one digit to not be 0 in front of the decimal point, I would have to move it to the right. And so 0.8 becomes 8 times 10. And since I moved it to the right, it's going to be a negative 1. So 0.8 is actually 8 times 10 to the negative 1. And that's being multiplied by 10 to the negative 5. Now, using a product rule, since I'm multiplying like bases, I'm going to add those exponents. So that's 8 times 10 to the negative 1 plus a negative 5. And a negative 1 and a negative 5 is a negative 6. And so there's the answer. 8 times 10 to the negative 6. And then finally, number 10. In number 10, we have 7.13 times 10 to the negative 3rd divided by 3.1 times 10 to the 7th. All right, so grouping the coefficients and grouping the powers of 10, we get 7.13 divided by 3.1 times 10 to the negative 3rd divided by 10 to the 7th. Now let's go off to the side and figure out what this one is. So I have 3.1 divided into 7.13. Move the decimal point. Remember, you got to make the divisor a whole number. So I'm going to move it one place, move it one place here. So that's 31 divided to 71.3. And so 31 will go into 71. Oh, and let's bring up the decimal point. 31 will go to 71 two times. 2 times 31 is 62. 71 minus 62 is going to be 9. Bring down the 3. And 31 goes into 93 exactly 3 times. 3 times 31 is 93. You get a remainder 0. And you can always check 7.13 divided by 3.1 equal 2.3. All right, so this right here is 2.3 times. Now remember, quotient rule, we're using a quotient rule. We divide like base, you subtract exponents. So that's times 10 to the negative third, subtract 7. Now, negative 3 and a negative 7 is a negative 10. So that's 2.3 times 10 to the negative 10. Now, notice this time it's already in scientific notation, so I'm done. So you see right here, there's only one digit in front of the decimal point, and it's not 0. So that's it. That's your answer. All right, so that was the key to the worksheet on scientific notation. All right, so scientific notation, that was the key to scientific notation.